sure that this function is continuous, and polynomials are continuous everywhere. We want to make sure it's continuous on the domain from -5 to 0. And then it's about doing this. Here's my function. It's a polynomial, so it's definitely continuous here. Then you want to take the derivative. And you can see if I blow this up, I've marked it as the derivative. And then what you always do is find the average slope between the points and set it equal to the instant slope. So you find this by filling it into the original and always set it equal to the derivative. Slope equals slope. This is f of -5 minus f of 0 over -5 minus 0. You're just finding geometry slope and set it equal to your derivative, like this. They'll have you pick the points from -5 to 0 so that you can visually see the slope that you're looking for between -5 and 0. There's one that happens back here also, but it's not in the domain that we're looking at. So what I did was I finished up the algebra. All of this was 7, and then I subtracted 7, and I factored, and I got 2 answers, but I had to throw away this answer right here, so you're going to see it disappear. I had to throw away that answer because -20 over 3 is not in this domain that they asked me for, -5 to 0. So you'll see I only typed in -2. And in fact, I was prepared to give 2 answers and realized the other one was outside the domain. And so usually you wouldn't even have that second box there unless you needed it. Oh, and it gives you a nice picture of what's happening, where at -2, that's the moment in time they are parallel. So remember, parallel, set your derivative equal to the slope between the endpoints, as long as it's continuous and differentiable. So when it says, let's see, it might ask you if it satisfies the conditions of the mean value theorem. So make sure it's continuous and differentiable before you start.